So I want to do something different on Sundays from now on, and kind of like look at a concept of programming and try to dive in a little bit deeper. Maybe also inspired by some talks that I've been watching. And there's especially this one talk by Sandi Metz, which is highly recommended. I mean, she comes highly recommended as a speaker, and the topics she speaks about. I would suggest watching all of her stuff. But there's especially one talk called Nothing is Something, which is a very interesting way of looking at object-oriented programming, and kind of really outlined for me where I was maybe taught the wrong things and also thought about things in most likely the wrong way. And especially using Golang as a test bed here can really demonstrate something. So if we just open a main file, the reason why this is interesting to use Golang is that you do not have classes. And many people, when they think about object-oriented programming, they think that classes are a prerequisite of that. Like, you need to have classes to have objects. But in Go, we have objects. Like, I can make... okay, let's put a scenario out there. Like, let's say that we have an application that needs to write files or data. It needs to write some form of byte data, either to a file or to some other source. Could be a database, could be a network, could be storage on the cloud, right? Okay, so we'll do storage on the cloud and local file storage. Those are the two writers that we need. So what do we need? We need a local writer. So this is that object. Like in Python, oops, you would do something like let's make the main.py as well. You would do something like, obviously, something like that. Local writer. Let me spell that correctly. And have something like that, right? And then you have your init function, which does nothing. So that would be the Python version, but here we'll have structs instead of classes. And they don't follow entirely the inheritance model as you may be used to. They use composition, but you can very well do forms of inherited behavior by composing it together. So we also need a cloud writer, and this would write to a file system on the cloud. Like, I do this a lot now with, like, for instance, Google Drive. No, not Google Drive. Google Buckets, cloud storage. And so we'll have a main function. This is kind of freestyled, so we'll probably make some mistakes along the way in this video. And some typical behavior, what you would do, for instance, is saying like, okay, let me let me make some constructor functions so I actually know what I'm doing. So we'll have a new local writer that just returns a local writer. Yep. We don't need to initialize any state in there. And this will return a, well, what am I doing? It always gets you that typing and thinking about the video as well, again. And that returns a cloud writer. So what happens now? Well, in a situation like this, what you one second as I fix this. What you would do is something like okay, so we'll have for instance like a local writer is a new local writer, and we'll have a cloud writer that is a new cloud writer. And for instance, you would say something like, okay, well, the cloud writer will write, and that will return an error. And then if the error is not nil, then the local writer will write. And I'm not passing in any data here, but just think about it having like I don't know, some sort of a byte stream input. So this would be the file data, right? And that's the thing you'd be writing to wherever you want it to go. So now let's implement those methods real quick. So we'll need a method on the local writer. So actually we can call that writer, and then reference the local writer and create a write method which returns an error, and that error will just return nil for now because we need to return the right type. And then here as well we'll have a cloud writer write method which returns also an error, and let's make that nil. Obviously in this you would have something like, and let's make that pseudocode, like it'd be something like error is, and then some package built in that has a write method that passes in that thing, and then you just return the error. It will be nil if there was no error, so it will revert to that state, and otherwise it will actually return the error, which is then handled here to say like, okay, we couldn't write to the cloud, so write to local file storage until we can retry that process. Maybe the cloud was down, maybe there's some other reason, and we want to implement a retry mechanism. Now there's inherently nothing wrong with this code. It's just that in this very basic example it looks quite clean, but you could see that if you have many different types of writers and you have many different types of scenarios and states that you want to respond differently to, you will get a lot of if conditions and a lot of if-else conditions. And if you've ever seen code, hello Boogie, the dog wants to join the video I suppose, but he cannot climb up here. If you have many different, well, if you've looked at code bases before, you will see this behavior all the time, everywhere. If statements to, I mean, if is our bread and butter, right? Like that's how we create the logic in code. However, it's not a very object-oriented way of approaching your logic. Like objects are supposed to be specialist objects that perform behavior and that can construct more complex objects. Think of a factory pattern or an abstract factory pattern that can construct other objects. That's the real meat of object-oriented programming. Boogie, you're kind of messing up the video. Yeah? So what we can do here to go to something a little bit more sane is like, what if I wanted to just not care about this behavior in my main function? What if I wanted to do something like, I want to have a new SafeWriter. I'm going to call it SafeWriter. There'll be some links of inspirational videos that I take this from in the description of this video, because this sort of comes back to another talk I've seen. So here we will create a type called SafeWriter. It'll be a struct. And let's see, what does it need? It will need a yeah, well, I mean, we could even just do even better. It will have a couple of writers. So how are we going to do this? That will be a list of what we call a writer, which we haven't got yet. But did I just call it a list? I meant a slice or an array. Now I'm embracing the Python all of a sudden. So we'll have a new SafeWriter method to construct this thing, and that returns a SafeWriter, and what it will take in is a list of writers, which will be a slice of writer, an array of writer, return a SafeWriter, and just make sure that writer is assigned. So now we have an object here that that wraps other writers. So it has an array of writers that is at this moment of a type writer, which we haven't implemented yet, that type. We're gonna do that now. Now here things might be a little different than in the Python world or in the dynamically typed world. But embrace this for a second, because this will translate, and you can translate these concepts very easily to any language, because they're not specific to a language that, for instance, uses interfaces as heavily as Go does it. We need to create a writer type which is of type interface. What that does, it defines a contract to adhere to. If you adhere to this contract, you are of that type, which is really useful because it means that we can kind of combine and compose types together. So what you need to do for an interface is define which methods it needs to implement to be of that interface. So in this case, it's actually quite easy. You just need the right method, which returns an error. So that means any type that implements this write method with an error return will be of the type writer interface. That means that local writer indeed has, right here, its write method, which returns an error. The same thing here with the cloud writer. It has a write method, which returns an error. That means both of these are now of the type interface writer, right? That means what I can do now is say here, in fact, I want to do this a little differently. I kind of forget the syntax, but I think it's like this, and then I think it's like this. Let's see. It does not like that, so maybe I don't need to do that. Actually, I don't need to do that, do I? So what this does is kind of like a splat argument. So what I can do now is I can go here and I can pass in a new local writer, and I can pass in a new cloud writer, and delete these, delete this, delete all of this. And just to make Go happy and have it not show up as an error there, we will just consume that into nothingness for now. But what we have now is we have a SafeWriter that gets 2 writers, or an arbitrary amount of writers passed into it, and adds that to its array of writers. So what I can do now is, if I make a new method on the SafeWriter and call that write, and it can, in fact, I don't even want it to return an error. I want it to return nothing. Because what I will do is I will wrap the error in here, and I will actually wrap multiple errors here. And that will be an array of error. So what will happen now is we need to actually make that array and assign some space for it. So that will be an error, an array of errors, and let it grow automatically. Or in this case, you could probably even just say like it's of size 2, because we're only going to return 2 errors in this case. So what we will do here is loop over our writers. So that will be writer.writers. That's actually bad naming probably. So yeah, and now we can call, we actually, what we will do is good question. Go here. There's multiple ways of approaching this. What I will do is I will create an error. I will instantiate that, and then just do error equals, what did I say, w.write. So now we're calling the write method on our cloud writer and local writer, because we are looping over the writers that we pass into SafeWriter. And so we will do that, and then say if error is not nil, and we take the writer.errors and append the to the writer.errors. It's weird syntax in Go, and then append the error. So, right. Something is not happy. Forgot a keyword. So now we're looping over every writer that we've passed into our SafeWriter, and we are just collecting the errors of the different writers. So what I will do here is I will just call w.write. I do not care about anything that happens under the hood of the SafeWriter. Like it will just figure out that, you know, it needs to write to local writer or write to cloud writer. In this case I'm looping, but I could do all kinds of stuff. Like our previous behavior was to just say, we could say writer the writers 0, which is in this case the local writer, and call write on that first, and catch the error obviously, and then if that fails, write to the cloud, whatever, like the same behavior that we had before here. I'm just looping over here to demonstrate the concept. And now I can say, well, if I wanted to, and I had some sort of a logger object or something, I could say like, well, to my logger, or I could say like if, well, I wouldn't even care. I'll just send the errors to my logger, logger. And I will have a method called log errors, and then I'll just pass in the errors. And that's actually not possible. I need to make a change here. Let's do that correctly. In Go, everything that is capitalized is an exposed method or variable, and everything that is not capitalized is not. So, I don't have a logger object obviously, so it's gonna be angry with me. But as you can see, like I've lost the entire logic here with the if and the else and stuff, and just put that in an object somewhere that is a specialized object, a SafeWriter, that deals with other writers. And this is a very sort of, for me, that was kind of a revolutionary concept. I never thought about it. Maybe this is something you learn in computer science or whatever, but for me, again, as this horrible word of a self-taught programmer, this was really an interesting way for me to think about things, and it really made me excited about refactoring my code using these sort of new concepts. And I think this is a really great sort of introduction to this concept of exploring object-oriented beyond it just being about classes and inheritance and patterns, because I'm starting not to be entirely sure whether or not I will do these only on Sunday, but I really want to look at how design patterns are really, they have something to do with object-oriented, but you don't need object-oriented as a concept to implement design patterns. You can do that in functional programming as well. And then functional programming can also be object-oriented. And I want to explore these concepts. But for now, I think this is a really interesting little tidbit to look at and to think about. And let me know what you think about this.